Welcome to our CCNP class, everybody. Thank you so much for being here. Got a couple things. Exactly, Nicholas, where Viral comes in, which is now called CML, Cisco Modeling Labs, which, by the way, Cisco Modeling Labs, there is a Cisco Modeling Labs Personal, and that is basically it's what used to be called Viral. It's a legal way of doing basically a lot of people do oh god, what is that called? Help me out, somebody. Where I'm drawing a complete blank.
But isn't Cisco Viral? They don't have serial links. All they have is Ethernet. Is that correct?
No, well, they've got the ability to do some serial links, but it's mostly Ethernet, yeah. But you can do GNS3 and have serial links, and they're working on it. But honestly, serial links are so uncommon now. Almost everything's an Ethernet link anyway. So, but you can buy Cisco Modeling Labs for personal. It's like $200 a year, and you can put up just 20 Cisco routers or nodes into it. There are some limitations, like I said. Right now, it doesn't support or has not supported serial links. I don't know about the new 2.7 version. I haven't downloaded that or hadn't had it. You can actually try it in a free sandbox here. So you actually can go in here on Cisco's website and you can log in. In fact, let me see if I can get I might try to log in and see if I can get in here. Let me see if I can get in this. If it'll let me in. They've broken out our username passwords on Cisco. That's weird. That is so weird. Yes, it won't, for some reason, will let me do it. I'm just going to go back to DevNet Sandbox. Go to DevNet. Well, let's see if I can find the sandbox. DevNet's got all kind of stuff you can do from sandbox. Let me see if I can find the CML sandbox. We actually had for 2 years, we had a full Cisco modeling labs set up here on our campus. But here's Cisco Modeling Labs. This is only version 2.7 though. And see, it's not even working. They don't even have it. They don't have the. All right, so they got something wrong with that Nginx is not working, so you can't even get into the sandbox. But they do have that as an option if you want to try CML. It lets you do some pretty advanced networks. Okay. And that's unfortunately fairly common with DevNet. Sometimes you get in there and stuff doesn't necessarily work correctly on that. I want to talk a little bit about finishing up the class. Just kind of what's got to be done here. Obviously, you need to get your 25 labs done in NetLabs. You need to do the exams inside of in netacad.com. And I know there's only a couple inside of there. So when we go into netacad.com, we look inside of here, you'll see that in the assessment center, I have created activations for you till 5:15. You've got all of these exams. There's what, 1, 2, 3, there's 6 of them that are available in here. There's no packet tracer. There is a course feedback and a final exam. Now the final exam is still active. The current final exam is active to 4/11 at 11:28. I will actually go ahead and let's see if I can't extend that another 7 days. So it's 4/11 at 11:28 is what it's set to now, 11:28 a.m. So we'll do 11:29 a.m. And then I'll extend it for 7 days from there, as far out as I can from that. So it'll be 18th. And then when that actually expires, I'll extend it again. But remember, you've got to do the written final and you've got to do the hands-on final. So
So
Okay.
when does the class actually end?
Our class actually ends, the end date is, what is the final day of this course? This one ends on the 8th of May is our official end date. So 1 month from today.
1 month from today.
1 month from today. So do the exam from NetiCat, which that is the chapter exams, the course feedback, and the written exam, written final. And I would like for you to make a 70 or higher on that written final. And you can take it again if you need to, but try to make a 70 or higher on that written final. Remember, there are no discount vouchers in this class, unfortunately. But you need to get that done. And then the final thing you got to do is the skills assessment final. Final in NetLabs. And I'm going to show you that in just a second. This one is easier. Those of you who had Encore, you will learn that this one is much easier. But it is inside of our class, our NRC class. It is this Skills Assessment 1 PMAP. You got to complete that for me. And I do have inside of our class, I should have an upload for that in down here at the bottom somewhere. Yep, skills assessment upload. So you're going to complete that document, save your config, stick those configs at the end of the document, and then upload it to me. Okay. So that is what's got to be completed to finish this class, and to be given your certificate of completion, basically be completed, and then you'll be able to apply for your continuing education credits if you want to do that. All right. Any questions about what you've got to do to finish this class up? Many of you have already done that. I know there's a couple of you finished already. I've had like I think 2 or 3 of you finished. And I just got to get through and grade all your papers. I graded everything in my CCNP 3 class. I haven't graded everything in this class. So, other questions on what's required to finish this course? All righty.
You gave us on the Encore class. You gave us a Word document with I think with the final on it. I'm not sure. I don't remember.
Word document with the final. Oh, you're talking about, okay, I know what you're talking about. You're talking about the you want the final for the skills assessment in a Word format?
Yes.
Okay, I can do that. I'll put it down here under skills assessment on the hands-on. I see what you're saying. You want me to do, and I'll have to go into it and actually grab it and turn it in. Actually, you know what? I don't have to do that. I've got the ability to go get it. And this is actually something that'd be good for y'all to know. Once you're able to, you're actually accredited to teach a class, one thing you need to realize is you can always go into resources, course resources, find the class you're teaching. In this case, obviously, it's Enterprise Advanced Routing. And then all of the available resources will be underneath there. And so here's the skills assessment. All right. Now, I'm not going to grab this one because I've got to grab it out of NetLabs itself. But you'll notice here's the PowerPoints. Here's all the scope and sequence, all that you would need if you happen to be teaching this course. But I'm going to do a lab reservation and actually go get that document and convert it into a Word document. So I'll do that as part of what we're doing here. I'll just pull this over to the side and let that work while I'm also talking about some other things. Okay, so I will put that down at the bottom of the class itself, inside of Canvas. Now, there is one problem we're going to have. On May 8th, well, actually be on May 9th. So on May 9th, the class ends May 8th. So after May 8th, you will no longer have access to canvas.stanley.edu. So if you have not turned your 25 labs in Canvas, and you know that inside of Canvas, I've given you uploads for the labs here, but if you have not turned your 25 labs in Canvas after the 8th, I can give you up until our next round of classes start, which our next classes start on June the 5th. So you have until June 4th at the absolute maximum to finish this course out. Okay. Last day to turn in anything. Okay. But after May 8th, you can no longer put those labs into Canvas. You have to email them directly to me. Okay. So that's why if you can get it done by May 8th, get it done before May 8th. That way we don't have to have you emailing me labs. Does that make sense? You will still have access inside of the Network Academy. I'm not going to get rid of this course because this course will still be available and you can still do your quizzes. You can still do those things, but you're not going to be able to upload your individual lab assignments into Canvas after May the 8th. Are we clear on that?
Yes.
Okay. Everybody's good on it? Just want to make sure, because I don't want you to get in a situation where you're like, I don't know what I'm doing. I don't know what's happening. Okay. So, let me do this right here while I'm thinking about it. Any other questions about the class so far? Anything that's come up while I've been out and about sick? Okay. That'd be. Did everybody get to see the clips today?
No, I didn't. Saw it on the news.
All right, my thoughts on the certification, Nicholas. The Encore exam's the hardest exam I've ever taken in my life. All right, bar none. I'm talking CCI written, nothing I've ever taken in my life has been harder than the CCNP Encore. Okay. The NRC, I haven't taken it. I have studied for it, and the only thing that scares me is the troubleshooting. Because they've got so many different ways of putting things in the troubleshooting. I've got the exam voucher, and I hadn't had time to take it. So that's 100% my fault. I think it's going to be easier than Encore. And the only reason I think it's easier than Encore is because I think it's a little more focused than Encore. I think Encore is both wide and deep. I think an RC is deep but not as wide. So I think it's going to be, from what I've studied and what I've looked at, it's going to be a little bit easier than what we've done so far. Okay. But having said that, if it's like the Encore, it's absolutely unmerciful, because again, that's one of the absolute hardest exams I've ever taken in my life. I studied for over a year for the Encore, and I did pass it first try, but it was, again, I took a year to study for it, and I've never studied for an entire year for an exam. Same thing with the NRC. I'm taking over a year studying it, but I just haven't, I don't feel polished enough to take the exam yet. If that's kind of makes sense. I don't feel like I'm quite ready yet to take it. And that's, I don't know what I'm gonna have to do to get myself fully ready. Let's see what we got. I'd hope, not being sick this semester, I would have enough time to go through every single lab again in this class, and that was going to be my prep, but I have not been well enough. So, and there seems to be, every time I turn around, something else I've got to do from a work perspective. But it won't be long because I'm going to be retired before too long. All right, there it is. So there's your Word document of the skills assessment for NetLabs. So it's converted. And you'll also see in here that there are configs you need to drop in, that hopefully will be dropped in already, but you've got that available to you. So you've got a docx you can download. Mile wide, inch deep, yeah. Well, and I honestly, Nicholas, I think CCNP Encore is not a mile wide and inch deep. I think it's a mile wide and about 6 inches deep. Because it's pretty detailed. I mean, it's getting into some. That thing got pretty deep in the weeds, even on the wireless stuff. It got so deep in the weeds on the wireless that I was just like, holy moly. You know, it was almost like it was a full wireless exam on top of all the other stuff that was there. So, but I do have a free voucher to take the CCNP Encore because we were a instructor training center premier academy this year. So they gave us some free vouchers. So it's on my to-do list. I took a bunch of industrial control system classes and did some other things. So I didn't get to it so far. And I apologize because that really aggravates me not to have it and be able to tell you exactly. Of course, I couldn't tell you what was on it anyway, but I could give you some ideas. So let's talk a little bit about route maps. One of the things I've told all my classes early on is learn access control lists, because access control lists are used for everything. And you're going to see again, we're going to get into conditional matching with ACLs. So we're going to look at how we can use route maps to tune the network, to do matching of patterns of traffic, and then have something act on that traffic. You can even do this. One of the things you can do with route maps is you can say this traffic goes this direction, this traffic goes that direction. And it's a way to control or tune your network. They use it for talking about tuning the network. First off, of course, ACLs, they're used for everything. Quality of service, firewalls, route maps, you name it, pretty much anything that you're going to do, you can do it with an access control list. Be aware again, access control lists are sequential. They work top down. First item that matches an access control list entry is going to apply to a packet. At the bottom is an implicit deny all. So if it matches nothing in the particular access control entry, so the ACEs, that's what an access control entry is called, as an ACE. If it doesn't match any of those, it gets dumped. All right. So we have our two standard and extended ACLs. Of course, these are standard extended IP ACLs, and it can be IPv4 or IPv6 ACLs. You look at how we can do them named or numbered. Remember that. And this is just a quick review of ACLs. So if you do it with a name, IP access list standard, give it a name, it will be a standard access list. Can you remember for me what is used to, on a standard ACL, it only uses the source network in order to define what it matches or doesn't match. So a standard ACL needs to go as close to the destination as possible, typically, when we're talking about a standard ACL used for filtering of traffic. Extended ACLs use source destination protocol port. I talk about standard ACLs being the kind of the shotgun approach, getting in the ballpark, whereas extended ACLs are more like the rifle approach. They're dead on. You got to pick what you're going to use. Okay. Now, you can use ACLs to match networks. Okay. So you can actually go in and put an entire network IP any. So that would be any source, any destination. Remember, any is quad 0, quad 255, and it just keeps you having to write that out. Here's one saying permit all hosts in the 16 network to all hosts, permit all IP hosts from 16 to 31, so it's /12 range. Same thing down here, you're looking, but it's /16 range. So these are extended ACLs. Here's some BGP, looking at protocol and source. So again, it's just looking at how you can permit different networks based on that. Now we can do prefix matching, and this is looking at the prefix length, and all of us know now that everything really is looked at in a prefix length. And inside of an access control list, you just have to be careful because the first prefix length or first prefix that matches is going to be the one that applies. So you need to be careful how you put them in. And so here we can see matching different high order bits, depending on whether or not they match or not. Here's our prefix list. So you'll notice here, this is matching multiple different prefixes. So we got a prefix list here, and we're saying permit 192.168.00/13 greater or equal to 32. Okay, so this is greater than or equal to 32. So it's going to match everything that is .0.0 up to /13 greater than or equal to 32. And then on down, you'll notice all of these, it permits. What would happen if we did not have any permit statements in a prefix list?
Everything would be accepted.
Everything would be blocked. Everything would be denied. Because remember, at the end of the prefix list, if we had all deny statements and no permit statements, there's an implicit deny all. So everything would be denied. And it also depends on how you apply the list. Okay, it also depends on how you apply the list. Here we've got IPv6 prefix lists. Okay, now the reason this is important because we can take route maps and its very simplest form, again, it's like an ACL, but it has a lot of different things you can do with a route map. Okay, they're critical to BGP because they allow you to modify a unique policy. So you can use a route map to apply different policies into BGP. But we're going to look at our route maps here. So let's look at a route map.
One question, real quick. At the end of accesses, there's an implicit deny all. So the same thing applies with route maps.
No. With the prefix list, there's a deny all.
There's an implicit deny all at the end of every prefix list.
At the end of, I'm pretty sure at the end of prefix list, yes. Okay.
Okay.
But now here's how we're going to use them. Well, actually, no, I got that wrong. I'm sorry. It just won't apply. It just won't apply. There's not a denial. It just won't apply.
Yeah.
So it won't match it.
So if it doesn't apply,
which means it won't apply the prefix list.
But it means everything else will be permitted.
Right. Well, it won't. Well, let's think of this in a different way. Okay. Prefix lists are: do you act upon the network or do you not act upon the network? Okay. So with a prefix list, if it's not in there, it just means you're not going to act upon that network. So whatever you're trying to do with your conditional matching, if you don't put it in the prefix list, then the policy is not going to apply to that particular device or that particular network.
Gotcha.
Okay? So it's not going to deny it, but it's not going to apply your policy to it, which means it's going to just get normal routing with whatever's in the route table, and it's going to do whatever it can figure out on its own. Okay. So that's the difference. Does that make sense?
Yes, it does.
Okay. Now let's look at our route maps. So we've got sequence number. That's obviously the order it's going to be done. Permit or deny, an optional action. So let's look here. Following command, route map, name, permit, deny, sequence number, and then whatever the particular rule is or what you're going to do with it. So here, route map, example, permit 10, match IP address ACL1. Okay. So you should have an ACL1 somewhere that's going to match a certain number of addresses with your conditional matching. Match address 2, or ACL2, match address ACL3. Now notice here we act upon it. We're setting a metric for all of those inside of ACL3. And then at the bottom, permit 40. So this would be all other prefixes are permitted. Okay. Now the route map itself does have a denial at the end of it. So if you don't permit everything at the end, okay, permit 40, that basically is the permit all, then it would not, a route map would not allow things to go through once you apply it to an interface. Okay, or apply it to a protocol. So this is an example of taking a route map and setting the metric for all of those items under ACL3 to a metric of 20. Now, we don't necessarily know what we've done with these other ones, but whatever the route map is going to be, we're going to have those we're going to have that as we look. Now, you can also have multiple different matching things. So you could do multiple variables. So match IP address ACL1, ACL2, and or something like this, match IP address ACL1, match metric 500 plus or minus 550 plus or minus 50. So this would be, it has to match both ACLs, all right? And this one would be, it has to match ACL1 and it has to match a metric of 550, either 500 to 600. So plus or minus 550. So you can see you've got a lot of control here. You got tons of control with these route maps. Here's more complex matching, looking at deny, access list standard one, you've got deny and permit. So here's our access list. We've got matching these, denying 1.0 the network, permitting this every other 16 base network. This may be an example of blocking out your management network for some reason. And then you've got matching ACL1, match it, then deny ACL2, and set metric 20. Let's see, 2 minutes because match counts. Yeah, if it matches the deny statement, it will no longer be, none of the items after that will apply. Here's some more optional items. Using continue lets it continue on to map other ones. So that if it does match it, it will still continue to look at the additional items. So with continue, you can make it say, yes, it matches this, set the metric to 20, but also continue on and look at the other items in the route map. Now that's something completely new we've never seen before in any type of access control list or any type of filtering we've done at this point. Look at the type of control that gives you, and the type of ability to control where your packets go and what they're going to do. Now notice here's a route map that's setting the next hop IP address. Why could a route map like that be useful? Nicholas, you've probably seen route maps like this in your environment if you run BGP, because of the fact that you take a route map and what do you say? You say, we want all this traffic to go out this port or out this ISP and all this traffic to go out this ISP. So we set the next hop IP address so that we can actually force traffic to go out one ISP versus another ISP. We do that here on our campus. We force our traffic out one ISP, and then if that ISP goes down, we have an additional way for it to set to do a backup and go the other way. So we can do load balancing. We can do load balancing with our route maps. If you don't, your traffic's going to try to find the best path and just going to use that best path. Now, again, routers make all types of forwarding conditions. Here's policy-based routing, PBR. We can actually do our forwarding based on things such as protocol. So not only can we say that certain networks go a certain direction, we can say a certain type of protocol goes a certain way. We can assign different network paths to the same destination based on latency and speed and length. The big problem with policy-based routing is you can really get yourself into you can get into the fact that it can get so complex, you don't understand where your network's actually sending your traffic. That happened to us when we redesigned our network, and we had one group come in and start to do our BGP, and we honestly just, I don't think the guys knew what they were doing, honestly, but they had the policy-based routing so complex, we couldn't even understand the flow of the traffic in our network. So you have to be careful when you do this, that you don't create a crazy complicated set of policy-based routing. Now, you do have to do this for policy-based routing. You have to create route maps, okay? And then identify your conditional match, whatever that happens to be, IP address, length, whatever. And then you can set your next hop or other items that you can set, and then you apply the route map to an inbound interface, okay? So here's an example illustrating policy-based routing They're all configured OSPF, but we're setting up a policy-based routing that says ACL PBR, permit anything that is from 10.110 going to 10.550. So anything from 10.110 going to 10.550. Okay. We want it, if it matches that access control list, set the next hop to 23.1.3. So we want it to go up this way instead of directly across from R2 to R4. Now, that could be for various reasons. Maybe the route from R2 to R4 is not as stable, or maybe the route from R2 to R4 is more expensive, or maybe it's slower. Who knows? For whatever reason, we want the traffic from 10.110 to 10.550 to traverse R3 to get 10.550. So on R2, we create an inbound policy-based routing that says if it matches from 10.1 to 10.5, have it go up to 10.1, 10.123. 10.23.13, which would be up on R3. Okay. So what would happen then is, obviously, you ping, it would go across, and it would go up to the R3. Now, here's one of the problems you have. Because this has to be an inbound on R2 in this particular case, packets originating on a router are not policy routed. So you can do that with IP local policy route map, but by default, they do not do that. So you have to be careful where you apply these if you're trying to do your policy-based routing. If you want it to apply locally, then you have to do IP local policy route map and apply that. Now, there are a couple trouble tickets here. What do you think is the most common issue with policy-based routing? What do you think would be the easiest thing to mess up? Well, let's look at how you create it up here. One of the things is, it's got to match an access control list. One of the most common items is literally not creating the access control list correctly. So you fat finger the access control list or use the wrong networks in it. Another very common item is forgetting to apply it to an inbound interface. So you can create the route map all you want, but you'll notice the route map won't do anything at all until it's applied to an interface. And once it's applied to an interface, then it's going to start applying to that traffic going through that interface. So those are the types of things you'll see in the trouble tickets. Okay. Traffic from 140 to gig 110 is routed through R2 using gig 030, but it should be routed to R1 using FA10. And then so you'd want to look at the route map on 10.140, where 10.140, I gotta find 10.140, there it is. Is routed through R2, although it should be routed to R1. Now, this would be, obviously, one of the things here is probably going to be a local policy problem, because you're going to have to apply the route map locally for the branch router to apply it. So we've got these trouble tickets. Have many of you done these labs, the 15.1 labs? And I meant to ask you, Clay, did you get your problem fixed with being able to paste things into the net labs?
Yeah, I got that fixed, but I tried to do one of the earlier labs last night, and PC3, I think, never came up. I sent you a picture.
Do you remember which pod it was?
I'm gonna say one, two. I'm gonna say either 2 or 3.
Okay, I'm in pod 3 now. I'm in pod 3. PC1 came up. PC2 is up. PC3 is up. PC4.
PC3 came. Okay. Well, mine, I did it.
That's on pod 3. Now that's pod 3. It's PC1 came up.
Yeah, all of them came up except one.
Well, it's up on pod 3.
Okay.
Now, but I'm not, like I said, that's pod 3. I'm not in pod 1. Let me see if there's somebody in pod 1 right now. Let me see if it's Jackson pod 1. He's doing route redistribution. There's no PCs in pod 1 in that lab, so I can't check that. I'll check pod 2 here in just a second. But yeah, always, if you have a problem with the pod, please always let me know which pod it is.
I sure will.
Because I got to know which pod it is to be able to tell to check it.
Okay, I'll do that.
Has anybody else had any problems with the pods during labs? Okay. Most, knock on wood, been all right. We are going to have to do an emergency maintenance on our net labs. So we'll be taking them down for probably 30 to 45 minutes sometime in the next day or so. So be aware of that.
Much paper.
We'll try to send out an update, unless we just find a time there's nobody really on it, then we'll just jump in and start doing that.
You can suggest personalized.
Okay. All right, so we'll talk a little bit about route redistribution. So redistributing routes between different protocols. Obviously, multiple routing protocols. If you got EIGRP and OSPF, here's an example of needing to exchange those between the two different types of interior gateway protocols. You would have a router in the middle that's running both, and then that router would be responsible for redistributing the protocols from one into the other. Here's an example of mutual redistribution, which basically means you're going to redistribute OSPF into EIGRP and EIGRP into OSPF. So very, very common thing to do. You can actually, believe it or not, redistribute between the same protocol, because let's imagine we have EIGRP Autonomous System 100 over here, and we bought another company that was running EIGRP and they were an Autonomous System 500. Those two would not talk to each other immediately, so you could actually redistribute between them. Not as common, but it's possible. So here's our different types of sources. Static, obviously a static route. Connected would be an interface. EIGRP, OSPF, and BGP. So you can actually redistribute routes through those. Typically, we say it's not transitive. If you redistribute protocol 1 and protocol 2 and protocol 3, routes from 1 are not redistributed into 3. So in other words, if you take and redistribute from EIGRP and OSPF, it's not going to automatically redistribute that into BGP. You would need to tell it to redistribute into BGP as an external, as a additional redistribution. So don't think just because you're redistributing EIGRP and OSPF into BGP that those routes are going to be automatically redistributed between those two. You'll notice it doesn't. Here we've got EIGRP redistribute OSPF. OSPF is redistributing those two, and then on the BGP router only, it's redistributing OSPF. So you're not gonna, that middle router is not gonna automatically redistribute the EIGRP routes it learns into BGP. So you would have to go in and redistribute BGP into EIGRP on this protocol 1 and redistribute EIGRP into BGP. So you have to set up a redistribution between both endpoints. Let me see here. Now, this is a very important item about redistribution. The route has to exist. If the route is not in the routing information base or the RIB, it's not going to redistribute it. It's just kind of like, it's almost like, I've shown this multiple times in first level classes, and I like to do this. When you put an IP address on an interface, until you bring that interface up, it doesn't go into the routing table. Same thing with redistribution. Unless there's a way to get to it, it's not going to redistribute it. That way it's reachable. If not, it doesn't know that it's reachable and it won't automatically redistribute it. So if you have set up redistribution, but it's not being redistributed into your protocol, go and check your routing table and make sure the route that you want to get redistributed is actually in the routing table, that you can reach it. If you can't reach it with the protocol, it's not going to be redistributed into the other protocol. Okay. So, here's another thing. Every routing protocol does have a different metric or different methodology for calculating the best path for a route. Obviously, EIGRP uses bandwidth plus the sum of the delays. OSPF uses cost to calculate a shortest path tree. RIP uses a very simple hop count. The protocols provide what are called a seed metric at the time of redistribution, and that gets put into the route table. EIGRP default seed metric is actually infinity, so they're not put into the EIGRP table. OSPF uses type 2 external routes. We've seen that before. And route source and BGP get a seed metric of 1. All the protocols get a seed metric of 20. So that'll be when they first come in, there'll be a metric of 20 associated with anything coming in OSPF. BGP, the origin is set to incomplete, and the med is set to IGP metric, whatever the IGP metric happens to be, and the weight is set 32,768. So BGP puts its path vector information onto the seed metric. You can, for most of these, you can change that, and you can actually make it. You can set the seed metric you want it to have. You can actually set it up so it has a different one. Let's see what I can do here to figure out. Here's just looking at behaviors. Notice these have an AD of 170, so they're definitely not as trusted as a normal EIGRP route, which has a metric of 90. There you see the default metric command you can use. So I'm not going to go through this. We got the. Okay. Again, seeing you can do OSPF redistribution. This is if you get into a situation where you've got multiple area zeros, possibly you bought another company. So they actually will appear to be external to one another. It's possible to do it. It's not the greatest thing in the world, but it is possible. And then we've got RIP, all that. Okay, yep. All right. All right, everybody, that's all I've got for the day. I've got to stop sharing here and get out of the office real quick. Any questions on what you need to do to be working towards? Right now, it is April the 8th, so you have a full month. So you literally are, if you're around chapter 11 or 12, 11 to 14, or 11 to 15, you're actually in pretty good shape. You're not too far behind. This week, you should be working on chapters 15, 16, and 17, so the very chapters we were looking at. But if you're in that area, you're doing well, and you're fairly caught up. If you're not, try to catch up, okay? I'm going to stop the recording.